All right, we are getting there. 8 and 4, lesson 22, constant rates revisited. What are we going to do today? Well, today we are going to use what we've learned over the past few lessons. And just a second, and we will put our learning into practice. So that's what lesson 22 is about. It's about putting our learning into practice of what we've done the last few lessons. So we're going to do some word problems. Basically, learning into practice means word problems. And this is not something to be scared of. Hopefully, I make this easy for you and you totally get it. And there's a few little keys that we need to learn. And then the problems are going to be just like what we've been doing. So don't get nervous when I say word problems. Word problems can be your friend. And word problems, if you know how to manipulate graphs and do word problems, you're going to be the smartest one in the class. Okay, let's get going. The keys for today. When I say rate, you think slope. It is the same thing. Rates are slopes, okay? And we're going to do some examples here in a second, so you'll see what I mean. Now, the second thing is when we talk about a constant rate, we talk about a constant slope, right? If a rate is a slope, then a constant rate means a constant slope. And if we talk about a constant slope, we are talking about a straight line, right? Let's look over here at Helen's bike race. If this is a constant slope, the slope is the same all the way up. The slope doesn't change. It doesn't do this. It's a straight line. Constant slope, straight line. Straight lines mean linear equations. So this is how everything connects. Constant rates mean effectively linear equations. That's the connection that we're going to get to today. Okay, that's the first key. Rates are slopes. Constant rates mean linear equations. Now let's look at these units. We're going to talk this is going to be really key because you're going to see in a lot of these word problems, we're going to talk about a constant rate of 10 miles per hour or a constant rate of $10 or $16 per week. And when we talk about these constant rates, we're talking about, again, the slope, but the units of the slope are the y units over the x units. Okay, this is getting maybe a little bit complicated, but when I say $20 per week, I mean $20 per means divide. Per means divide. I mean $20 per week. So this number 20 is our slope. This dollar is our y units. And this week is our x units. And we're going to see that over and over. Up here, and we'll talk, when I get to the examples, I'll come right back to this. Okay, now the last piece is the x units. Whenever you see dollars and weeks or you see miles and hours, the x units are usually time. Almost always the x unit is time. So when you're looking at rates, the time goes here. Time goes on the x-axis, whether it's hours or days. So let's look at these two quick examples. We won't do completely the math yet. We're just going to talk about how these examples, these two graphs, relate to what we've talked about. Okay, so first of all, we note there's this little point here that we've graphed. We're talking about Helen's bike race, and this is how far she goes in a certain amount of time. And Helen rides at a constant rate. Rides at a constant rate. And how do we know it's a constant rate? We know it's constant. It is constant because B/C, because it's a straight line. Right? Straight line means constant rate. Okay, great. So what points do we have on this graph? We have the point in 7 hours, she's gone 90 miles. Wow, she's a fast rider. But we can see that this point here represents 7, 90. Now you can hopefully see how this fits into everything we've been learning. She started at 0, 0. After 0 hours, she'd gone 0 miles. So her rate, what is her rate? Well, her rate, or what is the slope? Slope equals rate. The rise is 90. The run is 7. So our M is equal to our rise over our run. If you punch that into a calculator, you can see that that's equal to 90 divided by 7 is about 12.6. That's about 12.6. But when we talk about word problems, we always talk about units. And let's go back to point number 2. Our units are our y units divided by our x units. So her rate is 12.6 miles per hour. Let's look at another example. Juan's savings. So Juan is saving money, and we're assuming he saves at a constant rate. How do we know it's a constant rate? It's because we have a straight line. Okay, let's switch to blue here. So let's see here. He started with 0, 0, because we have this point. After 10 days, he has $60. So let's see, what is his savings rate? What is his savings rate? Well, that's the slope. The rise over the run. The rise is 60, from 0 to 60 is 60, and we run 10. So his slope is the rise over the run, which is 6. And our units are let's go back here, are our y over our x. Our y units is dollars, and our x unit is days. So that's $6 per day. So Juan saves $6 a day. And that makes sense. If you save $6 every day, after 10 days, you should have $60, right? 6 times 10 equals 60. So that makes sense. Okay, so hopefully this makes a little bit of sense to you. Constant rates, these are word problems. Hopefully they're not too hard. Let's do 3 examples that kind of come at this from a different, each kind of looks at these concepts in a little bit different way. And all of these I'm going to call homework help. Now, first of all, we're going to lay down a few happy cats for you because, you know, this is great stuff. Word problems, that's the power of math. When you can apply math to real world problems. So let's look at this. I save, so this is a word problem. And here we go. I save at a constant rate starting with no money. After 8 weeks, I have $20. And I'm saving at a constant rate, remember. So graph my savings. So let's graph that. And then let's answer, what is my savings rate? And how much will I have after 20 weeks? This is kind of like the bonus. This is the bonus question. This is the bonus. But this is the basic. This is question number 1. Well, to do this, we're going to just go ahead and plot these points. Well, after 8 weeks, let's see, if after 8 weeks I have $20, that point goes right here. 8 weeks, $20. And we knew to put the, weeks is going to go down here on the x-axis, and why? The time is on the x-axis because that's pretty much the rule. I know some teacher's going to find some time out there, some reason that maybe on some graphs that weeks are on the y-axis, but time is almost always on the x-axis. And then so the other thing, whether it's money or distance or area or whatever, usually goes on the y-axis. So that's how we're graphing it like this. So what is my savings rate? So what does that mean? My savings rate, what are we learning? The rate equals the slope. So what is my slope? Let me draw this as a real line. Let's be proper about this. Let's keep going even. Well, let me just do it. Let's not keep going. Let's just do this. Okay. So what is my slope? My slope is my rise over my run. Let me do it this time. We can do it this way, up 20 plus 20 and over 8. We could do it that way, but let's just do it using our slope formula to make sure that we can, also do it both ways. y2 minus y1. So y2 is 20. y1, we have this point over here, 0, 0, right? That's this point, the origin, over 8, x2 minus 0. So that's 20 over 8, which is equal to, if you do your math, is equal to 2.5. Or 5 halves, or 2.5. Any of those numbers are valid. And so my rate, we need to also include our units. Remember to include units. And so that would be dollars per week. Dollars are y units over our x units. Just like our slope is y over x, our slope is our y units over our x units. So our y units is dollars per week. So I am saving $2.5 per week. Not a lot, really. That could be $2. You could say that's $2.50 per week. That might not be a lot for most people. Okay, let's look at this. So how much will I have after 20 weeks? Well, the point is here is we have to figure out, well, right here, after 20 weeks, how much will I have? Well, there's 2 ways to do it, or at least 2 ways to do it. So we can extend our line out and see. So let's just do that. Let's extend our line all the way out to 20 and see what happens. So this is our 20 line right here. So where would that be? Well, it looks like it's off of our chart, but we can just extend this line up and then we can see that that would be 60. Right? So after 20 weeks on this line at a constant rate, we'd have 20, is that right? No, it's not right. It's not right because I have the wrong, this is not 50 right here. I have the wrong units. Sorry about that. Let's get this right. 10 is 4. Every 4, we go 10, 20, 30, 40, 1, 2, 3. That would be 50. So after 20 weeks, we'd have $50. So let's write that down. And I guess this mistake that I just made, I have to highlight a key point. Whenever you're graphing, we'll do this in green. When graphing, keep intervals consistent. So if this 4 boxes is plus 10, then every time these distances have to be the same. Plus 10. Very good. Happy cat, happy cat, happy cat. Let's move on to another example. Okay, here we go. I run at a constant rate. Below is a chart my coach filled out to capture my progress. What is my speed? So maybe you want to pause and try, and I'm going to give you a hint that you don't need to graph all of these points. Just graph the easiest point. That's my hint. And there's a homework problem that's like this one. Just graph the easiest point. Okay, pause plus try. All right, I assume you've come back. So what's the easiest point? The easiest point to graph is this one. And the reason is that it's got integers. It's easy to graph integers. All of the other ones have fractions, so we're not going to use those. What's the other key? When I'm graphing, what do I put here and what do I put here? Well, I'm going to put my time, my minutes here. Why? Because time goes on the x-axis almost always. Okay, so let's spread this out. So I want to make sure I can fit a 25 on here. Maybe go 1, 2, 3, 4. I can probably put off, just go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is 20. This is 10. This is 15. This is 5. And I'm going to put my laps. I'm going to go 1, 2, 3, 4, 5. I'm going to actually use 5. 1, 2, 3, 4. 5 blocks for every point, every one lap. So we put our laps here. 1, 2, 3, 4. This is 3. 1, 2, 3. So I'm going to graph. After 15 minutes, I've gone 2 laps. So let's graph our line here. And there you have it. Now, what is my rate? Rate equals slope. So we'll go back here and we'll just say rise over run. Really want to get this into your head. Rise over run, rise over run. You'll never screw up if you think about rise, y over run. You run to the right and you rise up or down. So this is plus 2. This is plus 15. So 2 over 15. So I go in 2/15 laps, my y units, over my x units. So 2 divided by 15, that's about, I mean, for those of you who want to keep score at home, that's about, 0.13 laps per minute. But that's about. That's not an exact number because this is a repeating decimal. It's actually 0.13 infinite. So this is the best answer because it's exact. 2/15 laps per minute, that is my rate, that is my speed in laps per minute. Okay, let's lay down the happy cat. Hopefully you're getting the hang of this. And now we have one last example. And I think there's a homework problem like this one as well. Julie mows 7 lawns in 10 hours. And here is a graph of John's mowing rate. So this is John. Here, let's go back and let's put Julie, or no, let's just call this, this is John's mowing rate. John's rate. John's mowing. John's lawns mowed. Well, there's a couple ways to do this one, and let's do it both ways. So we know that Julie mows 7 lawns in 10 hours, so we know that her rate is 7 lawns in 10 hours. That's her rate, lawns per hour. And here's John's rate, lawns per hour, right? So if this is, let's see, this is 6,4. And let's use the point 0, 0 when we're finding our rise over our run. So +4 + 6. So John M is equal to 4/6 is equal to 2/3 lawns per hour, right? Our y divided by our x. So this is John's rate. Julie's rate is 7 lawns per hour, and that's 7/10. So let's just rewrite that just as a fraction, and then we'll put our all right, so the person that with the faster rate, the bigger rate, who has the bigger rate? The faster rate. Well, it's hard to compare 7/10 and 2/3, so we have to put both of these into decimals to compare. To compare two fractions, the easiest thing to do is put them into decimals. So 2/3 as a decimal is 0.66 repeating, so we'll go about 0.67. And 7 divided by 10, oh, that's an easy one. That's just take your 7 and move your decimal 1 over. So that's 0.7. And which number is bigger, 0.7 or 0.67? Well, 0.7 is bigger, so Julie mows faster. Okay, so Julie mows faster. So if Julie mows faster, I don't care if we're measuring how many lawns you mow in 30 hours, 10 hours, 1 hour, or 22 hours, or 2,000 hours. If Julie mows faster, she will always mow more lawns. Happy cat. Now, the other thing that you could do if you were adventurous or clever or creative is, or just thought about this problem differently, is you could put Julie's mowing on the same graph with John's mowing. So let's do that real fast. Let's just do that. For those of you, and I'm going to write it over here, and watch what happens. Whoever has the steeper slope will be the one who mows more lawns. So let's do that. And let's watch how cool this is. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is hours. I'm going to lay two graphs on top of each other. Watch how this works. 1, 2, 3, 4, 5, 6, 7, 8. So this is 1, 2, 3, 4, 5, 6, 7, 8. And so this is lawns. And this is hours. So let's do this. Let's do Julie in blue, in purple. Julie's lawns mowed. And we know that she does 7 lawns in 10 hours. So 10 hours, 7 lawns. So 10 and 7 is right here. And so we're going to graph that. And now let's graph, we'll do John in red. John's lawns mowed. And so he did 6. In 6 hours, he did 4. So let's graph that guy. And I think we can already see that John's a little bit slower. Not that much slower, but he is slower. So our answer is Julie's line is steeper. So her slope is bigger, is greater. Let's just say is greater. So greater slope equals greater rate. So that's the second way you could have looked at this problem. Just look at it visually. This is a numeric way of doing it. This is a visual way of doing it. And for those of you who thought of the visual way, happy cat to you. And hopefully these 3 different lessons, my goal is that with these 3 different pieces of homework help, that I think that you will be able to solve all of the homework for tonight, for lesson 22. Don't be scared of word problems. When you can convert all of the key words from the word problems, slopes equals rates, you know how to find the units on the graphs by taking your y units and dividing it by your x units. Comparing rates, comparing slopes is simply a matter of doing the math that you've been doing for the past 5, 10 lessons. And we are going to keep iterating on and doing some more of these word problems. But I hope this is helping, and let me know if it is. Subscribe, comment, tell your friends. Keep watching, and I'll keep teaching. You're welcome. You're welcome. See you next time. Lesson 23.